You're listening to DTFHN for April 11th, 2026. I'm your hand-filed host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who could be outside choose to argue about text editors instead. Today's got that beautiful, stubborn energy of people who refuse to leave well enough alone. Let's get into it. One commenter put it perfectly. They've been using a MacBook for 2 years, and their wrists were so cut up from the edges that it looked like self-harm. That's not hyperbole. That's a design choice someone made in Cupertino and a real person's skin paying for it. Kent Walters took a metal file to his MacBook, filed the sharp corners right off the aluminum unibody, posted photos, and the reaction split exactly the way you'd predict. Half the people wanted to talk about warranty implications. Half wanted to celebrate the act itself. The warranty crowd is interesting because it reveals something about how we relate to our tools now. There's a direct line from this moment back to 1984. Not the Apple ad, the other one. When IBM shipped the PC with published schematics, the entire point was that you could modify it. You could add cards, swap components, build peripherals. The machine was yours. Somewhere between then and now, we accepted a different arrangement. The machine is yours, but only if you don't touch it. You bought it, but you're licensing the right to use it in the manner prescribed. Walter's approach is methodical. He taped off the speakers and keyboard to keep aluminum dust out, clamped the machine to his workbench, filed in increments because he wasn't sure how deep the chassis was, finished with 150 then 400 grit sandpaper. This is craft. This is someone who understands their tool well enough to reshape it. It was actively degrading. Something about the electrical grounding when plugged in, combined with sweat, was causing pitting on the aluminum edge, a sharp edge becoming a serrated one. The machine was modifying itself just in the wrong direction. There's a phrase Walters uses at the end that deserves attention. Fuck around a bit. 3 words that contain an entire philosophy of tool ownership. Your drill press, your kitchen knife, your laptop. These are instruments that should conform to the hand that uses them, not the other way around. The fact that this is considered controversial when applied to a computer tells you everything about where the industry drifted. The takeaway one commenter identified is exactly right. Consider modifying your tools to your needs, even in unconventional ways. Especially in unconventional ways. The tools exist. The files are cheap, and your wrists will thank you. Now, if you really want to see what happens when someone takes a simple system and bends it to its absolute limits, pause. Let's talk Connect 4. Connect 4 has been strongly solved since 1988. Every position, every branch, every possible game state mapped and cataloged. 14 terabyte uncompressed. 350 gigabytes compressed. A monument to brute computation. And the conventional wisdom says, that's the end of the story. Game solved. Move on. A developer who goes by 2swap looked at that monument and asked a different question. What if understanding a game means compressing it down to what actually matters? Not every position, just the ones that lead to a guaranteed win. The result is weak C4. A strategy for perfect first-player Connect 4 play that fits in 150 kilobytes. Let me say that again. From 14 terabytes to 150 kilobytes. 5 orders of magnitude. And it uses zero search at runtime. Constant time per move. You could run this on a microcontroller from 1985. The engineering here deserves real admiration. What 2swap built isn't a lookup table and it isn't a search algorithm. It's a language. A formal description of the structural patterns that make Connect 4 work. Threats, double threats. The geometry of how 4 in a row actually emerges on a 7x6 grid. The strategy identifies a small opening tree where every leaf node can be described by these structural rules. And then, those rules carry you to victory without ever needing to search ahead. This is what the strong solution versus weak solution distinction reveals. A strong solution says, I computed every answer. A weak solution says, I found the underlying structure. One is a database. The other is comprehension. And here's why this matters beyond a 40-year-old board game. As one commenter pointed out, this builds on Victor Alice's original work but generalizes and streamlines the rule system. The approach. Distilling emergent structure from combinatorial complexity is exactly the kind of thinking that scales. Not more compute, better representations. Finding the right language to describe a problem so cleanly that the solution becomes small enough to hold in your hands. The entire strategy is visualizable, explorable in real time. Published openly, you can trace every variation, understand every decision. This is what knowledge looks like when it's built to be shared rather than hoarded. 150 kilobytes of crystallized insight sitting on a web page, free for anyone to study. The tools exist, the math is beautiful, and sometimes the most profound thing you can do with a solved problem is solve it again, better. Moving on. I once spent 3 days debugging a system where 5 perfectly correct components, each doing exactly what it was supposed to do, produced a result that was absolutely catastrophic. The logs looked clean. Every unit passed. The emergent behavior was a nightmare. That experience rewired how I think about security, and BlueHammer is the most elegant example I've seen of why component-level correctness means nothing. At the system level, a researcher just dropped a full privilege escalation chain for Windows Defender on GitHub. No patch exists. No CVE assigned. Works on fully updated Windows 10 and 11. Takes any low-privileged account straight to NT Authority system. And the source code is sitting there, public, with a dedication to Microsoft's Security Response Center for, quote, making it necessary. Let me play devil's advocate for a second. You could argue this is irresponsible disclosure, that dropping a working 0-day with source code endangers millions of machines. And in isolation, sure, that argument has weight. But here's what actually happened. The researcher reported it. Microsoft acknowledged it, then apparently reneged on whatever agreement existed, and the researcher ended up by their own account, without a home. The person with nothing left to lose is the person you created by breaking your word. The irresponsible disclosure argument evaporates when the responsible channel is the thing that failed. Now, the technical chain itself is genuinely beautiful in a horrifying way. 5 legitimate Windows components. Defender's update process, volume shadow copy, the Cloud Files API, opportunistic locks, and Defender's own RPC interface. None of them are buggy. All of them are working as designed. BlueHammer registers as a cloud sync provider, same as OneDrive. When Defender runs a signature update and touches a file in that folder, the exploit drops an opportunistic lock. Defender freezes. The shadow copy it just created stays mounted, and that shadow copy contains the SAM database with every local account's password hashes, normally completely inaccessible. From there it's a cascade. Read the hashes, decrypt them with the boot key, change an admin password, elevate to system, spawn a shell, then put the original hash back like nothing happened. Deadpan delivery. The antivirus is the attack surface. This is the comedy of unintended consequences playing out at operating system scale. 5 components, each reviewed, each shipped, each doing its job. The vulnerability isn't in any of them. It's in the space between them. And the full exploit is open source now, which means defenders can study it, detect it, and build mitigations, even while Microsoft figures out which team owns a bug that exists in no single component. The tools exist. The blueprints are public. That's how security actually improves. Sometimes the most delightful thing in tech is pure play. An entire orbital slingshot game, one HTML file, zero dependencies. Single HTML file. That's the entire game. No build sep, no dependency tree, no webpack config longer than the source code it bundles. One file you can right-click, view source, and understand. And it's genuinely fun to play. Starfling is an orbital slingshot game. You've got a ball orbiting a star. Tap to release. The ball flings outward on the tangent. And you need to catch the gravity well of the next star. Chain enough catches and you're threading a needle through space at speed. Miss, and you drift into the void. Now the comments reveal something wonderful. Multiple players are confused by the orbital mechanics, and they're confused for exactly the right reason. The physics don't match Kepler. Objects curve when they should fly straight. Gravity wells pull in ways that feel wrong if you've internalized how orbits actually work. And this is where the engineering decision gets interesting. Let's follow this to its logical conclusion. If you implement realistic orbital mechanics in a casual browser game, what happens? You get Kerbal Space Program, which is brilliant, and also requires dozens of hours to develop intuition for. Realistic gravity means elliptical transfers, delta V budgets, counterintuitive retrograde burns. It means most players never catch the second star. The developer made a different choice. The gravity is fake. It's tuned for feel, not fidelity. The wells are sticky. The curves are forgiving. The tangent release has a slight auto-aim quality that makes near misses into catches. This is game design as engineering trade-off. You sacrifice simulation accuracy to maximize the thing that actually matters, which is the dopamine hit of a 5-star chain at blazing speed. And the whole thing ships as one HTML file you can host anywhere, fork instantly, learn from directly. Someone already added it to HN Arcade. The entire game. Rendering, physics, input handling, score. Sitting there in view source like a textbook. This is builder culture at its most pure. One person, one file, one idea, executed cleanly. No login wall, no analytics payload, twice the size of the game. No framework abstractions between you and the code. The kind of project that reminds you the web was designed to be exactly this. Documents that do things. Source you can read. Software that respects you enough to show it's worked. The tools exist. A text editor and a browser. That's the whole stack. We talked about stripping things down to essentials earlier. Well, someone took that all the way to chess. One dimension. Story 5, 1D chess. In the 6 years after the jailbreak in mining, okay. Canoner the Louise, liking the opera relaby to, but the av permitted after, like can each tree after dough, to set never relevy, and gapping here and lasters the books. And where years to the Joe old complants and so. He made time, loved the masters. 40 years after his not as tad furthers. The mouser I decide Todd pull do, left to the old of a story. He sketched out the analysis and left it for readers to wrestle with. 46 years later, someone built it. One HTML file, playable in a browser, with an enemy opponent that will beat you if you don't find the forced win. And there is a forced win. White can checkmate in 5 moves with optimal play. The entire game tree is small enough to solve completely, which puts it in rare company. Connect 4 was strongly solved in 1988. Checkers took until 2007. Full chess remains unsolved and likely will for centuries. But 1D chess sits in this sweet spot where the problem is tractable enough for a human to reason through, yet tricky enough that most people lose their first few attempts. The knight jumping 2 squares, the rook sliding freely, the king boxed into a line with nowhere to hide. Your spatial intuitions from regular chess actively mislead you here. Run this forward. What does it mean that a 46-year-old puzzle from a magazine column can be turned into a complete, playable, solvable game by one person with a text editor? Gardner couldn't do that in 1980. He could describe the rules and hope readers would set up pieces on a strip of paper. Now the description is the implementation. The rules are the code. The essay plays itself. This matters beyond the novelty. Every solved game is a closed proof, a domain where we know the truth completely, and every one of those proofs started with someone stripping away complexity until the essential structure was visible. 1 dimension instead of 2. 8 squares instead of 64. The reduction isn't a limitation, it's a lens. The game is open source, forkable, viewable. Someone in the comments points out that 1D Go is also interesting and doesn't require any rule changes. Another mentions backgammon is essentially a 1D game that billions of people already play. The design space of constrained games is enormous, and the barrier to exploring it is now a single file and a browser. Gardner gave us the question. The open web gave us the answer anyone can touch. Games anyone can fork. Archives anyone can hear. Pause. Turns out the best collections are built by love, not budgets. A grandmother's dictaphone, that's what started it. In 1984, a teenager borrowed his grandmother's tiny recording device, walked into a concert, and pressed record. 40 years and 10,000 shows later, Adam Jacobs has what might be the most comprehensive grassroots audio archive of American independent music ever assembled. Think of it like seed banking. For decades, agricultural preservationists have been quietly collecting and storing seeds from heirloom varieties. Plants that industrial farming has no use for, that no corporation would bother to catalog, but that contain irreplaceable genetic diversity. Jacobs did the same thing with sound. While the music industry was busy deciding which bands deserved to be preserved on official releases, one guy with a tape recorder in his pocket was preserving everything. The headliners and the openers. The bands that broke through and the bands that played to 30 people and vanished. A 1988 Boogie Down production set. A 1990 Fish show that nobody in the trading community even knew existed. Kurt Cobain, 22 years old, politely introducing Nirvana to a small Chicago club called Dreamers 2, full years before the world cared. The equipment evolved. Dictaphone to Sony Walkman to data slotted state digital. But the method stayed the same. Show up, press record, document what happened. Club owners tried to stop him at first, then gave up, then started letting the taper guy in for free. He became, as one author put it, a cultural institution. Now here's the part that makes this a story instead of just a hobby. A group of volunteers across the U.S., And Europe is methodically digitizing and uploading the entire collection to the Internet Archive. Free streaming, free downloads, lossless FLACs, no paywall, no subscription, no rights holder pulling files because a licensing deal expired. One commenter said it reminded them of the old internet. And, yeah, that's exactly what this is. The old internet. The one where people built things because they were worth building and shared them because sharing was the point. Jacobs doesn't call himself an archivist. He says he's just a music fan. But the seed bank doesn't care what the farmer calls himself. What matters is the seeds are in the vault, and the vault is open. Open vaults are only useful if you've got the right tools to explore them. One person decided to find out what happens when you install every single Firefox extension. 84,000. That's the total number of Firefox extensions, not 84 million, not 800,000. 84,000. Someone looked at that number and thought, yeah, I can install all of those. And the first thing worth noticing is how they got them. Mozilla's add-on API is public. No authentication required. No apparent rate limits. You hit the search endpoint with an empty query and it just hands you extensions 50 at a time. That's a design choice. And it's the kind of design choice that makes projects like this possible. Nobody had to reverse engineer an OAuth flow or dodge a capture wall. The data was just there because someone at Mozilla decided it should be. The search API caps out at 600 pages, which gives you 30,000 extensions, roughly a third of the total. The workaround is almost comically simple. Change the sort parameter. Default sort gives you one slice. Sort by created gives you a different slice. Sort by rating, another. Sort by hotness, another. Deduplicate by slug. And you're at 67,000. For the stubborn remainder, there's an exclude add-ins parameter that lets you skip past the page limit by telling the API to pretend certain extensions don't exist. 20 extra pages per pass, constrained by URL length. It's the kind of methodical, slightly absurd persistence that defines tinkerer culture. The actual installation is where it gets interesting from a systems perspective. 84,000 extensions, all loaded into a single Firefox profile. The browser doesn't crash on launch. It crashes later in specific and revealing ways. The About: add-ons page takes forever to render, which led to a genuine discovery. Extensions.json, the file Firefox uses to track installed add-ons, gets serialized and rewritten in full on every single write. 13 years ago, it was a SQLite database. Someone migrated it to a flat JSON file, and at 84,000 entries, that architectural decision becomes visible in a way it never was at 10 or 50 or even 1,000. This is what happens when infrastructure is open enough for people to stress test it in ways no product team would ever prioritize. One person with Bun and a free afternoon services a performance regression that's been quietly accumulating for over a decade. The browser is open source. The API is open. The extensions are open. And now the bug report basically writes itself, because every layer of the stack is inspectable. That's not a philosophy. That's just good engineering paying compound interest. So what happens when you stress test not a browser, but the entire concept of leaving Earth? Story 8. Artemis II splashes down. What does it take to trust a machine with your life? Not theoretically, not in a simulation. 4 human beings strapped into a capsule, accelerated to 25,000 miles per hour, and aimed at a patch of ocean they picked out weeks in advance. Artemis II just splashed down safely, and the fact that we can say that sentence casually is itself a kind of miracle. Let's break this down to first principles. Re-entry is a thermal management problem wrapped in a navigation problem, wrapped in a communications problem. You have a vehicle hitting atmosphere at Mach 32. The heat shield on Orion has to handle temperatures approaching 5,000 degrees Fahrenheit. Hotter than the surface of some stars. And the margin for error on the entry angle is roughly plus or minus half a degree. Too shallow, you skip off the atmosphere like a stone. Too steep, the deceleration kills the crew before the heat does. NASA threaded that needle. They landed when they said they would land, where they said they would land, down to the minute and the mile. One of the comments that stuck with me? Someone explaining to their family that this precision isn't luck. It's math. Decades of orbital mechanics, computational fluid dynamics, materials science, all converging on a single point in the Pacific. The engineering is genuinely beautiful. And this is the first crewed lunar distance mission in over 50 years, the last time humans went this far from Earth. Nixon was president, and the onboard computer had less memory than a modern thermostat. Artemis II flew with modern avionics, modern life support, a modern heat shield. And still had comms glitches where mission control had to ask astronauts if they were actually pressing the push-to-talk button. Some things about spaceflight remain stubbornly analog. What makes this worth celebrating isn't just the technical achievement. It's that this is a public program. The data comes back. The designs get published. The lessons learned feed into every future mission, every commercial crew vehicle, every international partner. When SpaceX, or ESA, or ISRO builds on what Orion demonstrated during this re-entry, they can because the knowledge isn't locked behind a licensing agreement. 4 people went to the moon and came home. The math worked, the engineering held, and the blueprints belong to everyone. I promise, this show makes sense as a whole. Story 9 takes us from lunar re-entry to primate politics in Uganda. One commenter put it bluntly, after a respiratory virus killed more than 10% of the population, the survivors split into factions and started killing each other. Sound familiar? The Ngogo chimpanzees in Uganda's Kibo National Park were, for decades, the largest known community of wild chimps. Around 200 individuals. Then, a respiratory epidemic tore through, 25 dead in short order. And what had been one group fractured into 2. For the last 8 years, those 2 groups have been waging what researchers are now formally calling a civil war. Lethal raids, territory seizures, targeted killings. 13 dead so far, all from the smaller faction. The comment section on this one is doing exactly what you'd hope. Pulling the thread between observation and implication without flinching. Richard Wringham's coalitionary killing hypothesis gets invoked immediately. The idea that coordinated lethal violence between groups isn't a bug in primate behavior. It's a feature selected for adaptive. One commenter flags the deeper backstory that the original Ngogo group itself expanded through conquest in the 90s, absorbing neighboring territory after killing rivals. The war isn't an aberration. It's a sequel. And then there's a prime directive argument. Multiple people genuinely debating whether researchers should intervene. Should they pick a side? Broker peace, the consensus lands where it should. Observe, document, publish, shams off. Which brings us to why this research actually matters beyond the grim novelty of chimps at war. This is a 28-year longitudinal dataset, open field research, published methodology. The paper is in Science, and the data trail goes back to 1995. Any primatologist, any anthropologist, any grad student with library access can build on this work. That's how knowledge compounds. One team watches chimps for 3 decades, publishes everything, And suddenly, every theory about primate violence, coalition formation, post-epidemic social fracture, all of it gets tested against real data instead of speculation. The uncomfortable mirror here isn't that chimps wage war. We knew that. It's the sequence. Pandemic, social fracture, factional violence. The comedy, if you can call it that, is how predictable the pattern looks from the outside. And how invisible it remains from the inside, whether you've got prefrontal cortex to spare or not. Moving on. Let me be honest about the strongest case against what the Linux kernel just did. You could argue this is performative, a feel-good policy document that changes nothing material. AI-generated code is already flowing into every major open-source project, whether maintainers know it or not. And a tagline in a commit message is about as enforceable as an honor code at a take-home exam. The skeptics in the comments nail it. A human signing off on AI-generated code they don't fully understand is theater, not accountability, and the licensing question is genuinely unsolved. How do you certify GPL compliance for output from a model trained on the entire internet? You can't trace provenance. You can't audit the training data. The policy says the human is responsible, which is a little like saying the driver is responsible for the car's engineering. Here's why that argument fails on its own terms. Rewind to 1900 when Linus Torvalds posted his famous "Just a hobby, won't be big and professional" message to comp.os.minix. The entire Unix establishment had a stronger version of this same objection. How can you trust code from random people on the internet? No corporate oversight, no formal verification, no liability chain. The answer wasn't that you solved trust theoretically before accepting patches. The answer was that you built a process. A culture of review, attribution, and accountability. And you iterated on it in public. The developer certificate of origin itself didn't exist until 2004, 13 years in. It emerged because the SCO lawsuit made provenance tracking urgent. Process follows reality. It always has. That's exactly what this document is. The kernel maintainers looked at the landscape and did what they've always done. They wrote down the rules, made them public, and kept the door open. The assisted by tag is genuinely elegant engineering, not just attribution, for attribution's sake. It's structured metadata, machine.parsable. You can query it. You can track which models produce patches that survive review and which ones generate churn. Over time, that data becomes a feedback loop for the entire ecosystem. And the craft here matters. They didn't ban AI contributions. They didn't require some impossible certification regime. They said, the human is accountable. The tool gets credited. The process remains the process. The same patch review. The same mailing list. The same Linus telling you your code is wrong in colorful language. The real story isn't the policy. It's that the largest, longest-running open-source project on Earth just treated AI tooling exactly like every other tool in the history of the kernel. With pragmatism, transparency, and an open door. The blueprints are public. The process is documented. Anyone can participate, human or otherwise, as long as a human stands behind the work. That's not a liability shield. That's how you build things that last. This has been your daily tech feed for Hacker News for April 11th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something worth sharing. We'll see you back here tomorrow.